All right, dear Sabbatical Leave Committee, here is a quick video to help you understand what I did for my sabbatical project for fall of 15. Since there are a lot of digital recordings, I thought it might be better for you to see them in a video. So I made this quick little video for you in addition to the hard copy summary. So there were 5 general research project objectives. Digital recording of these professorial lectures, which are basically pictures of me doing some things in class. Manual formula-based problem-solving techniques, computer-based problem-solving techniques, and of course we need to store and modify, and we needed to enhance the web pages with some images and some videos, and then we collated and edited everything so that it's a nice, comprehensive set of teaching modules. So I'd like to go through these steps one at a time. But if we go down to the creative work objectives, this is a better way of looking at it, I think, because the work objectives did add one more component rather than just the digital recording. It added these problem-solving workbook exercises that I created for each of these chapters. So let's look at that first. Okay, we go over to the course website right here. And the first thing I learned is you had to blow up the websites pretty large, up to 225%, in order to get decent amount of clarity via YouTube, and it's still not ideal, but it's good enough to get the job done. If we go to the homework link right here on this home page, you'll see I've generated all these workbook problems that weren't there before for this course. So if we just go to 1, measures of variability, we can see there's a host of questions. We have some raw data, what's called group frequency data down here. And the students have to either generate variance or standard deviation. And so those are the new problem sets for them. The answers are all right here for them. They click at the bottom and they can calculate. They have the answer and it shows them the formula they're supposed to use and a step-by-step way to solve each problem. Okay, so this just goes just beyond the problem set in the back of the book and gives them much more work. This is something the students have been asking for, if they could have more of that. And I was able to accomplish this, generate it with for all 15 lessons. So we have the problem sets for all 15 lessons. Let's look at the next goal here, where these things called Professorial Lectures. Now this is the one section that I modified a little because it came pretty clear pretty quickly that long videos aren't good. The best way to deal with these videos are short clips, hopefully less than 10 minutes and usually less than 5 minutes. And so I decided to break them into section by section in each of the lessons. And the other thing that seemed apparent was they didn't really need to see me standing in front of the screen lecturing. So instead, I used these screen grabs via this Camtasia software and almost sort of voiceovers of the lessons. And I'll show you exactly what those are. Let's go look at some of those. So we go here. Let's go to the schedule. Let's go to the lesson on correlation right here. And you'll see we have these are these lessons. They're in many of these sections of the lessons. There's an MP4 version and there's the YouTube version. So let's go to something, let's go to this Scatterplot. So we click on this, goes right to YouTube. Correlational data is best represented graphically by what's called the Scatterplot. This is a plot we introduced back in lesson 3. Scatterplots are great graphs because they're very descriptive. So you have your 2 variables on each axis, variable x, variable y, whether it's height or weight or depression or self-esteem. Those are the 2 variables you put on the axes. It really doesn't matter which goes on which axes. And then you look to see if you can see a relationship between these. In this scattering, you really don't see much of a relationship, as opposed to something like this, where you do see a relationship. As you can see, I can voice over the lessons, I can use the cursor to guide the students, and it seems like just a cleaner and neater and more efficient way of making these recordings rather than having a picture of me up in the middle of the classroom doing it. And it seemed to work really effective, and the students are appreciating that. So I made a great many of those, and I did them for more lessons than I said I was going to. Some required, 9 videos. Some required as many as 10 videos. Again, all smaller videos, section by section within the lesson. The third thing I did were these manual-based problem-solving techniques, which I really call calculation problems. These are problems where it really was beneficial to show the professor in front of the room going through a problem step by step. And I did this again for more than I said I was going to do. So let's look at some of those. If you go to these, let's go to the lesson on the normal curve. And let's just scroll down. All right, so here is the MP4. Here's the YouTube version, just stepping through the lesson. But in addition, in some cases, I have these calculation videos. Like this one here, it has an MP4 version and it has a YouTube version. Okay, now it's time to find some proportions. Okay, this is the first one we're going to do. So, for all of these exercises, we're going to use the same data. We have a mean of 71. This test exam was 71. It had a standard deviation of 14. This particular. So as you can see, it's a stepwise procedure of what the lesson I'm trying to give. Let me jump to a couple things. Step 2, step 3. Put this right up here first. Step 2, calculate the z. Now this is exactly the same thing I would do at the review session, or what do I do if I was teaching this lesson face to face. If we scroll down a little further, there's a couple nice little features to right about here. That answer. Let me back up just a little. I'll do that again. 3 is z to the n. So you can see now where we're going to find our answer. That's right, in column 3. So now it's off to the z table to find that answer. All right, so here's the z table we got here from the lesson link. And we want to scroll down, and in column 1, we want to find our z-score of 0.21. Well, there it is. And again, you can see the simple editing, but it goes from one video, purging 2 videos together. This is real simple, easy to use in Camtasia. I made a bunch of these. And I think these will definitely enhance instruction. You can see I made a bunch of these calculation videos, more than I said I was going to. For computer-based problem-solving techniques, this we did with the computer exercises. And I'll show you that now. Let's go there. These computer exercises are in the homework link. And if we go to, let's do the last one, computer exercise 3. And let's go to the lesson on one-way ANOVA right here. And let's look at this YouTube version right here. So in these lessons, we're teaching the students. Now let's calculate a one-way ANOVA in SPSS. All right, so we have a new set of data right here. Still involving the same notion, experimental drugs to reduce impulsivity. There's our dependent variable. But now, if you jump up right here, you can see how we step through the actual software. And 2 as the high dose of the drug. Okay, remember now, we have a 0, 1, and 2, so this is the modification we're going to have to do with our Excel data. I'll show you that in a minute. That's okay. And of course, in this way, we can step through the software, whether it's Excel or SPSS, and the students can follow the lesson. All right. That takes us to, I believe, the final phase, which is section 5, where we collate the material into one cohesive set of teaching modules. If we just go to the sampling distribution lesson, is probably a good one to see here. We go to sampling distribution. This was a PowerPoint presentation and I converted back into a web page, and it has the videos, it has some new images to show probability and a difficult concept, a theoretical construct in statistics. And then at the end of every single lesson, I've added at least 5 of these additional video links from other people's pages.
Let's take a look at the sampling distribution of the sample mean x bar. I'm going to assume that we are sampling from an infinite population, or that we are sampling only a...
There you go. So that right there sort of concludes the last bit of collation of material and creating all these extra sites. So I hope that was helpful for you. Please read my summary, the hard copy of the summary right here, and if you have any questions, don't hesitate to ask. Thanks so much.